Today we're going to do a review of the ISO tip soldering iron. It's a rechargeable soldering iron. This is the model 7700, and we're going to do some comparisons of this versus the standalone soldering iron that you can buy at the retail store. This will get up to 900 degrees in 10 seconds, and it can solder up to 125 solder joints per charge. Fully recharges in 3.5 to 4 hours. Partially recharges in 1 to 2 hours. Alright, so we're going to compare this to the regular soldering iron and the pros and cons for it. I'm going to talk about that after we talk about the corded one. This corded one you can buy if you work in electronics. This is not a isolated transformer. What that means is this has the potential to ground AC voltage, and you can potentially damage your electronics by doing so. And I'm going to move the camera up so you can see. So I got this on AC. I'm going to go to the neutral side of the plug. You can see that's the neutral. And we're going to touch the soldering iron. That's showing 68 volts. And it's showing different voltages. Nope, that's 68 volts. So you have 68 volts on that soldering iron as it gets hot. I'm going to check the other direction. Make sure I don't have that type of weird. Get a good connection. So it's 68 volts. So you have 68 volts on the soldering iron. When you first plug it in, it's 32 volts. When you let it heat up, it's 68 volts AC potential to ground. So when you solder that to a surface mount component, this is LEDs, and you can see there's nothing hooked up to it. I'm going to see if I could try this. I've done it before, and I made these LEDs light up. And if you can have voltage on this soldering iron, make this light up, and you're going to damage somebody's television set by using this. You could potentially damage somebody's television set. You can potentially harm yourself by plugging this in and working on the set, even though that you might have this, it's not unplugged, which is the standard thing that I would do. I would leave this plugged in with the power strip stripped off, work on the set, plug everything back in, see if it worked. If it didn't work, I would turn the strip back off. That way I would still have everything as quick as possible. The TV sets, when I was working on them, I went to the person's house. I didn't bring the set home, because you have to have a free bed or a table that you can make so your screens don't get scratched and whatnot. So you're working at a person's house, and surface mount components do not take much voltage to damage. I'm going to see if I can take this and actually make it light up. It won't light up for this video, but in the past I have made them light up. Okay, so that's a bad example, but you have 68 volts on this. So if you go 68 volts across a live power wires that you may not know that it's this, you could actually harm yourself. This tip is a copper tip. They can blow copper chunks everywhere, fragment. Hot solder and hot copper can go in your face. So we're going to talk more now on this battery operated one. They don't say that it's an isolated soldering iron, but if you think about it, you have no voltage to ground, because there is no ground. There's no path to ground. I'm going to open this up. Here's the charger. Pretty simple. You can actually probably take it apart if you wanted to. We may do that. Like the little electronics channel, we can do that. They give you a manual. And they give you two soldering iron tips. The small one and a flat one. And on the right side, this is how they have it packaged. On the right side, here's the soldering iron itself. This is not bad. Oh, okay, so you want it to be off. There's your lock. You can't press it. You want to use it, you rotate it up to use. It has a battery. It's already charged. And it's got a light here so you can see the surface that you're working on. Which is good because if you're working on stuff and it's in the dark, you want to be able to see what you're working on. And it'll heat up. So in 10 seconds, this thing's supposed to heat up to 900 degrees and it will melt solder. So we're going to take, I'm going to take the fatter tip and I'm guessing without reading the manual, there's two tips here. There's two holes. And I'm going to guess we just stick them in there. Probably should just read the manual. So that makes changing the soldering iron tips a breeze, if that's the case. So let's read the instructions. They give you all kinds of examples for what you have for soldering iron tips. Alright, installing tip. Align tip leads over terminal hole. Push inward and upward until tip is fully seated. To remove, press straight out, or pull straight out. If it's desired to attach tip permanently in the terminal, remove the two terminal screws and take them off the spring. Take off the two springs, then insert the tip in the tip holders and replace the screws and tighten. So, alright, you can take and easily remove this and then put in another tip just by doing what I just did here. And I don't think it's supposed to be that hard. It's probably just me. Alright, so that's where it's at. So, it's supposed to take only 10 seconds to heat up. I'm going to go find some solder. So before I started the soldering test, I had to plug it in. It did not come pre-charged. You have to, with the batteries and stuff with the postal service these days, it's more beneficial not to have them charged. Cheaper to ship in uncharged than anything. One thing I will say I would like, if they were to do this for other people, is one manual for one style, because recharging part of this manual here is pretty confusing at first. When you stick it in, it's pretty simple. It's got knots and it's got the little arrow thing there. You can only fit it in one direction in the holder. It doesn't lock down like I would expect it to just sit and lock. It's just spring-loaded contacts and that's how it sits. There's no indicating that it's charging. A little small surface mount LED here would have been, you know, if it's 12 volts, it would have been beneficial to have something you can say, hey, I'm charging. Because in the recharging section here, a couple different paragraphs that says different things. It's kind of confusing. The recharging stand is designed to be operated in 110 volts, 50 to 60 cycles. To recharge, place the ISO tip in the recharging stand with the push button toward the front. This is the push button. To recharge using the wall plug transformer, plug charger cord into the bottom of iron and plug charger only into a 120 volt AC receptacle. There is no wall plug for this. I'm guessing you can buy a plug and stick it in there. I would hope that they wouldn't suggest that this is 120 volts. We can check that. I could be wrong. And we'll find out. My power plugged in. It is not 120 volts. Output here is actually 2 volts. Probably will take and go higher once you have like a load on it. Do a battery test and see if it actually will do anything. Still 2 volts, okay? So I'm not sure what this has. If this is only putting out 2 volts, you don't want to put 120 volts into that, according to their manual. Recharge from dead to full charge. In this model, for the quick charge and pro power units, the power pro units in 3 to 4 hours. And then it's talking about the recharging stand for the 7944 and 7904 had the LED to indicate charging status. I know this is the basic model and it starts out at $50. But the basic model I think should have the same indicator. If not here, on this, on here. And it wouldn't take long or much circuitry to make that happen. So, it's been on charge for 1 to 2 hours, and I'm going to just see what happens. It seems to be still on. So let's see how long it takes to melt the solder. 3, 4, 5, 6, 7, 8, 9, 10, and we have solder. It does heat up in 10 seconds. Now, does it say how long it takes to cool? Doesn't, which is fine. So, the benefit of having something like this is it's not attached to a cord. That's one thing I will say. This is better than a standard wall plugged in. You don't have a cord attached to you. You can take it out to your car. You can take it out to somebody's house. And you just have this. Always make sure that you have it down in a lock function. You know, maybe if you had a switch or something rather than a dial. I mean, it serves this purpose, but remember to turn it to the lock when it's not in use. So, I'm going to show you a different application where this is going to be beneficial for me, and it would be more for an industrial setting, for working with different stuff. Especially when you're working on TV sets, you don't have the non-isolated soldering iron that can blow up surface mount parts. So let's just show the next clip. Let's say you're working on your lawnmower. You need to resolder something because the wire got spliced somehow. This would be a perfect tool for that. Be able to heat it up, splice some wires together, and then you're done. Let's say you're at a factory and you need to take and just replace the part. And for this system like this, it has a power supply that can have the capability of putting out 15,000 volts while it's operating. You want to make sure that you have something that's not connected to ground in case there's not might be a capacitor or something that would discharge. So something like this would be beneficial to solder circuitry. Something like this would be able to be used on, say, motorcycles. When you're trying to solder wires, instead of just using a wire nut, and you're putting in new LED strips to make it fancy. Or, in past videos, say you're working on your strobe power supply for your airplane, or your dump truck, something like this would be beneficial. Something small and handy. So, since this is an electronic channel, let's take it apart I do not advise you taking this apart. You potentially could and would void any of all your warranty with this soldering iron. But curiosity, I just want to see what kind of circuitry they have inside and what could be done to make something such like a small LED to be just put in here somewhere in the casing that you can do at home to let you know that, hey, it's actually charging. So anything that I can help, I'll do that. So let's see what happens. I know in fact we'll probably have to take this bulb out. I think the bulb is probably one of them you push and you turn. You may just pull it out. I don't know. Anyway, let's see if we can take it apart. I may take the bulb out. There we go. Now the bulb is out. And wow, that's pretty cool. So here you go. This is the inside. How it works. It's just a simple battery. You basically are just heating up the element with the battery. And that's it. Huh. I'm looking at the, must be a weld job on that they would have to take on those 2 points. I would expect some type of circuitry somewhere more than just 2 batteries. Alright, so here's my answer. 2.14 volts and 1300 milliamps. So in fact all you are doing is you are putting, you have a lot of current that you can use, and you're putting that across those 2 terminals. So when you turn the switch, you can't press it down. When you turn it this way up, it allows you to be able to press this down. So when that happens, now I understand why they did it the way they did. You're actually taking this copper plate and you're pressing it down on this terminal for this wire, which is also the positive for the charging down here. It's very simple. They share the same ground, so that's how the battery turns on. When you press down on that, the light turns on at the same time for the bulb. That's pretty simple. I like that. Unique. Low voltage, low powered. Awesome. Now something I would have done differently, since this is only 2.8 volts, I believe is what it said on the battery. Can't remember now. I would have actually made this an LED and make it so it's the same socket as that if you needed. If not, just make it so it's just an LED, because you could put a resistor on there. And the LEDs will last so much longer than what this bulb would have. And it's not glass, so if you were to drop this glass bulb will break. Yeah. So that's what I would have done differently. LEDs are pretty cheap. This is probably a lot more expensive than just a small LED that you can put in there. And you can put a resistor in there for a voltage divider and it would have worked just the same. Might actually have been a little bit brighter than the bulb itself. So that's just a suggestion. If anybody watches, it's from the company. So if you're interested in getting one of these, go to www.iso-tip.com. That's iso-tip.com. It's a pretty handy little tool. I think it would be a great deal for anybody that's into it. If you're a hobbyist, if you're a full-time technician, something like this, 50 bucks, go to somebody's house, you can put this in your pocket. Maybe make a little tape or something. You can stick this on there for your bit. That's what I'm going to call it, your soldering iron tip. So you don't have this exposed. You can put this in your pocket and carry it around as long as it's locked. That's pretty awesome. Pretty cheap and robust. And since I'm about to end the video shortly, I decided to show you a little bit of modification that I've done to this. I've inserted a 1 LED goes across the positive terminal for the charger, and I realized, just kind of a dumb of me, I didn't realize, but this here is meant for storing your little soldering iron bits. It's a quick and easy way to put it there. And check this out. So now, when you plug it in to the power, that would have been perfect. Now you notice the device is charging. And you can show you the LED is lit. So, this is what I would have done to make it that much more better. 5-cent part. Thanks for watching, guys. That's my review. I'll see you next time.